Very well. I'm delighted to launch the third episode of our interview series exploring artificial intelligence and agency. The rapid development of artificial intelligence in recent years has stirred interest in core philosophical questions, such as whether machines can achieve genuine forms of thought and agency. Through this series, leading philosophers and scientists will offer their perspective on that topic. And we are very fortunate to have Professor Jenann Ismael on our guest, as our guest in this episode. Professor Ismael is affiliated with Johns Hopkins University. She previously held positions at Columbia University, the University of Arizona, and the Stanford University. Her work spans several areas, including the philosophy of physics, metaphysics, philosophy of science, and cognitive science, and the philosophy of mind. And she is, amongst other things, renowned for her contribution to understanding the relationship between physical laws and freedom of will. And in her work, How Physics Makes Us Free, 2016, she addresses the longest-standing debate on free will and its compatibility with physics. Her contributions contribute to influence contemporary discussions on nature of free will, determinism, and the role of science in understanding human agency. Professor Ismael, thank you very much for accepting our invitation.
Thank you for having me.
So I will start with a very general question on the basis of what you say in this wonderful book, How Physics Makes Us Free. How come that human beings can have some sort of agency or free will in this physical world?
So there are a lot of different things that one might be either by agency or by free will. And depending on how strict you are in your requirements for either of those things, you might have something that runs the gamut from sort of simple living things all the way up to things that are thinking or cognizing, or in particular doing the sorts of things that we do. So I've focused in that book on both kind of primitive forms of agency and on the kinds of agency that arise when you have a system that's not just responding to features of its environment in a way that are sort of designed by evolution to produce advantageous responses, but systems that are collecting large bodies of information, storing it internally in their minds, and then using that information to guide their behavior in a way that really depends on, sort of deliberating about the world and having goals and doing things in order to realize those goals in a way that's explicitly represented in a model of the world. And that's the kind of thing that we do. It's a kind of thing that's kind of characteristically human. We don't know how much of the animal kingdom that does the degree of representing themselves in the world that we do. So it's a little bit hard to say how far that extends into the animal kingdom. But for me, that's paradigmatically of what one might think of as deliberative agency. And the sort of freedom that we have, something that I'm happy to call freedom of the will, is something that attaches to that much kind of, internal cognitive complexity.
Oh, all right. So this distinction between simpler forms of agency and then more complicated form, is it related to how you set a distinction between self-organization, self-governance, and self-constitution? I mean, by do you think that freedom of will, on the basis of the last point that you made, is having this kind of internal state, is something that comes with self-constitution and self-governance, what is not necessarily present in simpler forms, such as just self-organization in different kinds of complex systems? Would it be?
So, yes, but with a reservation. I mean, I think one of the things, so I'm gonna answer that in a second, but I'm gonna say something first about there's this large debate in philosophy about what free will really means and what would really count as free will. And to some extent, I don't have a dog in that fight. I don't want to put this forward as a definition of free will. People have different ideas about what free will is, and I don't want to fight about what the meaning of free will is. So in some ways, what I want to do is say, what kind of freedom do we have? if we treat ourselves as natural systems. So I do think that there is this kind of freedom that's closely associated with what I'm calling self-governance and self-constitution that arises in that setting. And that is different from these simpler forms of freedom or agency or whatever you want to call it, that systems that don't do the things that I say fall under the heading of self-governance and self-constitution. So with the qualification that you might have some completely other notion of freedom that involves not being governed by physical law, but the kind of freedom that we have is a freedom that arises from self-governance and self-constitution, perfectly naturalistically describable types of cognitive organization. So yes, I think those are kinds of freedom that we have that simpler animals don't have. And a lot of what I talk about in the book is kind of organized around this idea that that kind of freedom is really distinctive and it's a real kind of freedom and it's important.
Okay. And aren't this self-organization, self-governance, it is not incompatible with being a physical being or faring in a physical environment, is it? I mean, just
That's correct. And self-governance is different from self-organization. So self-organization is a thing that arises actually outside the scope of living things. So it's a well understood or fairly well understood dynamical phenomenon. Lots of examples of it. They arise in things like lasers and, fluids. What self-organization is when it arises when you have a bunch of physical elements of whatever kind. They can be components, microscopic components, they can be larger components, but you get a bunch of them together and you can see arise at the emergent level of large collections or ensembles of them, a sort of organized behavior. But in those settings, there's nothing like the kind of a central organization that's coordinating their activity. The organization at the collective level arises just because you have certain kinds of feedback loops that are happening within the system, but without any central organization. So you get the appearance of collective activity at the level of the system as a whole. Self-governance is something more. Self-governance arises where you do have some kind of centralization of information and coordination of the activity of the components of the system. And that's the kind of thing that happens in sort of human cognition.
and with regard to these internal states, how do you think about them? Do you think of them in terms of, I don't know, for example, minimal models of selfhood, self models, states of consciousness? So what's your theory of these internal states? How do you describe them?
So the way that I describe in the case of a self-governing system is you do have a system that is on the one hand composed of components, and those components are behaving the way they do because of the kind of local and roles that those components share. I mean, that governs their activity. But you also have at the global level an integration of information that's being sent by the components to some sort of central organizing subcomponent of the system. So think here of something like a company. So that's an organization where the company is composed of individual units. In this case, we'll imagine people. And the people are, on the one hand, they're gathering local information, and that local information is guiding their behavior. But they're also taking information and they're sending it to a central committee, like an executive committee. And the information at the executive level is being combined and integrated. And there's a decision procedure at the collective level that makes an all things considered judgment on the basis of the information that's being sent up by the components. And the deliberative procedure that's happening at the component level is something over and above what's happening at the individual level. So if you think of the human mind as doing something like that, it's got a bunch of submodules that are collecting information. So you can think here of kind of pre-deliberative drives and, sort of sensory motor subloops that are doing things like, I don't know, governing how the pupil is responding to kind of local information, guiding the way that your limbs are responding in a way that's not being consciously governed. So your legs do all kinds of things that it gauges sort of balance and things in ways that you're not consciously guiding. But what's also happening is that sensory information is being sent to a central part of the brain where visual information is integrated with audio information, is integrated with a sense of proprioceptive awareness of where you are in the environment. That information is being used to update a map of your environment. It's also being combined with your general, very kind of high-level cognitive understanding of the world and your place in the world. And when you're making a decision, all of that information is coming together. You're using it to form an understanding of where you are in the world, and your much more high-level cognitive understanding of who you are, what you do, the goals and plans and projects that you have. And when you make a decision, you're saying, all of that information is being brought to bear and being brought to bear kind of in a centrally coordinated way on the question of what do I want to do? What should I do in the here and now?
All right. I think that this is an excellent opportunity to start to discuss artificial systems as well, because when you were mentioning integration of information, the example that you gave was basically about unity of perception. So, I mean, integration of modalities of perception, how vision and sounds and other things are going to come together. So do you think that this kind of integration of information that is related to having internal state is something that can happen only in biological systems like us? Or do you think that also artificial systems too are capable of embedding such integration of information as well?
So yes, I mean, I think that's one of the things about thinking of us in naturalistic terms, because there shouldn't be anything that we can do that artificial systems couldn't do. As a matter of fact, the kinds of artificial systems that have been, so rapidly developing in recent years, and that the focus has been on in the development of artificial systems are not in fact embedded intelligence. So if you think of LLMs right now, they're not actually agents. What they're doing is they're sort of learning there's a sort of training phase, and there's an execution or inference phase, and they're getting information from the language. So they're converting statistical patterns in the language into speech. And they're doing it in two phases. So they're being trained in the one phase where they're getting feedback and the weights are being set in the neural network, and then feedback stops and they're in an inference stage, which means they're executing whatever learning they did in the early phase, in the training phase, to produce text in a way that's supposed to mirror statistical patterns in language. So the kind of intelligence that I was talking about earlier is very different. It's an embedded intelligence that's getting real-time feedback on its own action. So it's acting in the domain that it's representing. It's getting real-time feedback, and it's kind of always learning so it doesn't go through these two phases, this sort of training phase and inference phase. It's always learning. It's always getting feedback, and it's doing this kind of real-time updating of its internal model of itself in the world. So it's very different in some ways than the kind of artificial intelligences that have been kind of in the spotlight recently. So one of the things that people have talked about is, how do these kinds of intelligences differ from us? And on the one hand, we are explicitly modeling the world. They're mostly not. They're not developing causal models. They're not implementing this sort of real-time feedback and, to update a causal model and acting on the basis of it. That means they're not getting kind of real-time feedback on their own actions. They're not thinking of themselves as agents in the way that we do. So bringing them closer to real-world intelligence of the kind that we have would mean, doing something more than just equipping them with a world model. It would mean thinking of intelligence more in cybernetic terms, in terms of embodiment, in terms of feedback, in terms of acting in the domain that they're representing.
Very well. Yeah, I want to eventually develop this question to ask if there is any condition on the degree of integration of information to lead to internal states and so on. Because I understand the point that this information has to come through different channels, and then it should be updated, causal models getting updated and so on. But there is some sort of cognition, of course, also in animals, other kinds of animals other than humans, and it is very embodied. But do you think that they have some sort of agency or freedom of will? I mean, so in a sense, I do not think that it is, for you, it is not only about integration of information, but it seems that there should be something else to promote that, to self-governance, self-constitution, emergence of selfhood, which eventually comes with this sense of freedom of the will.
That's right. So let's put AI aside for a moment and look at sort of simpler animals. It kind of, in the regime that Dennett introduced when he talked about kinds of minds. So with the acknowledgement that there's lots about animal cognition that we really don't understand, we can nevertheless come up with simple schemata that we can use to understand this sort of progression from very simple types of responses to the environment all the way up to human cognition. So we expect animals to fall somewhere along that spectrum and continuum, but there's so much that we don't understand in specific detail about actual animals. So I'm going to use these simple schemas. So let's start with a kind of simple system. It's a living system. So it has kind of metabolic needs, and the way to satisfy its metabolic needs is that it needs to have its behavior attuned to changes in the environment in a way that will lead it towards food sources and whatever additional practical to reproduce. So imagine, for example, a simple bacterium whose food sources are in oxygen-rich environments. So it needs to be able to guide itself towards oxygen-rich environments in order to access food. So a system like that will need to be able to respond to kind of environmental stimuli that will, kind of gradients in oxygen, so that it will be able to be moving towards, where there's oxygen. But it doesn't have to have much going on internally in order to be able to do that. It needs to be able to respond to an external gradient, to external stimuli, in a way that will lead it towards rich sources of oxygen. But that can be a direct tie between motor responses and stimuli. What happens, though, is that systems that need to do more sophisticated kinds of thing will need to have more internal processing of the information that's impinging on its kind of sensory surfaces. And what happens in the animal world is you see more and more internal machinery that's specifically devoted to taking the information that's coming into the sensory surfaces, extracting useful information from that, rerouting that information to produce much more complicated motor responses. So by the time you get to a system like us, you have systems with brains, and those brains are designed to extract information from stimuli and use it to produce sort of complicated behavior. So intermediate along that route from sort of simple bacteria to systems like us, you have things like frog brains. So think about the frog brain. It's one of these kind of often studied systems. But what does a frog brain need to do? It needs to be able to recognize the presence of flies, because that's what frogs eat. And the way that it responds to the presence of flies is that it will, when there's a fly coming back, it will need to dart out its tongue and catch the fly. But what does it actually take to do that? First, it needs to be able to recognize from the very complex visual patterns that are always kind of, streaming across its retinas. It needs to be able to recognize those that are characteristic of the presence of flies. And then it needs to be able to predict if a fly is coming by. It needs to be able to predict from the current trajectory of the fly where it will be a minute. But all of that can be hardwired. I mean, sort of it can be part of the hardware. So flies over time, the brain has been designed to do exactly that. It will the eye will recognize, the presence of a fly, and it will produce the behavior that sends its tongue out at exactly the right kind of speed to meet the fly at the right place and bring it back. But one fly, once you have the frog brain that's designed to do that, so one frog, will be just like another frog brain. That stuff will all get hardwired in. Okay? Systems like us are much more sort of flexible in our responses to particular stimuli. So you and I, when we're sort of presented with the same visual array, will do very different things. Why is that? Because what we're doing is something much more complicated. We're taking information in at any given point. We're storing large bodies of information. We're using it to do what I said before. We're developing an explicit model of the world and how we respond to a given stimulus on a given occasion. Unlike a frog, sorry, I have to turn on my signals. Unlike a frog is going to be, thinking about what to do, kind of using the information to combine it with all of the other things that we know about the world. We've got different goals, much more complicated than, is that food? Shall I eat it? So that's what's happening, that we've got, much greater internal complexity, and part of that internal complexity, and part of the internal complexity in particular that I think is connected to free will is that we're representing ourselves as systems in a world that's distinct from us. We've got a sense of our history and our future. All of that is part of what's characteristic of human cognition. It's that representation of self, an understanding of our own history, representations of our own future. That kind of machinery is deeply implicated in the kind of freedom that we have. So that's what I mean by deliberative agency. We don't know any other animals that do that, at least to the degree that we do. There may be some, because there's, we don't know much about dolphin cognition. We know almost nothing about whales. But as far as we know, we do that more than any of the creatures that, whose cognition we have a sense of. And there's a lot of capacities that seem to us uniquely human that hinge on doing this kind of representation of self and deliberation and so on.
Perfect. So, and this kind of self-organization that leads to that underlies the emergence of self-governance, that underlies the emergence of self-constitution, the sense of historicity, the degrees of freedom. Do you think that these things can be also designed into artificial systems, artificial agents? Could these systems be designed, or they necessarily need to be evolved in an environment like us? The kind of embodiments that you have in mind, is it something that can be designed, or it is something that is necessary evolve from?
So these are the kinds of questions that one never knows until one tries to do it, but I see no barriers. to doing it. So this kind of cognitive organization is, in some ways, once you do have an embodied system, so an artificial general intelligence that's also embodied in a system that's moving around the environment that it's representing and getting, kind of sensory real-time feedback and making decisions, in many ways, that's the natural home for an artificial general intelligence. So we know, for example, how to design chess computers, and that's what chess computers are doing in a very simple way. They're representing, so if we have a chess agent, that is, these systems that are designed to play chess, they're acting in a very limited domain. So the world of the chess agent is the chessboard. It understands what it is in the sense of what its deliberation controls. So if I'm a chess agent that controls black, you're a chess agent that controls white, it understands that it has a kind of distributed agency in the domain that is its world. And it's making decisions in a world with other agents, about what to do. So it's gauging the current state of the board. It's representing its own future. It has a goal in mind, and it's making decisions that are going to bring it closer to its goal. And it's doing that, moreover, in a sophisticated way that's very much like what we do, meaning it's representing its adversaries, and it's representing the thought processes and the deliberation of its adversaries. So that kind of intelligence, which is, before LLMs, before, systems that were doing other things like trying to process sensory information, we were actually focusing in the early stages of AI on the kind of cognition that really does involve deliberation and guessing what other agents are doing and acting in the domain that it's representing.
Yes, I understand that very well. And I also agree that these are precisely the kind of answers that one can't know before facing the situation. What made me, and the thing is that I gather that you do not think that agency, freedom of will, because we were discussing this kind of self-organization and so on, they couldn't be directly reduced to the physical properties of the system as such, can they? And this kind of complex behavior that emerged. And what my question, what struck me as odd was that how could you design emergence? I mean, you can design the machinery, you can design the system, the complex system, and so on. But how would you ensure that something as sophisticated as a self emerges from this kind of design, this kind of architecture?
Okay. So a couple of things. First, the two stages are self-organization, and then self-governance. So those are two different things. Once you have a system that's processing information, so for example, once we have a computer whose low-level physical activity has been constrained so that the emergent activity, the emergent behavior of the system as a whole, is one that is doing something functionally, like processing information, which is what, current day computers are designed to do, and what, moreover, the naturally evolved brains of all systems, from, sort of frogs all the way up to us, is designed to do. You can take a system like that and put it inside a system that is, an embedded agent, whether it's, sort of an animal of some kind, or whether it's a robot of some kind. And now you have a system that's doing two things. It's an embedded agent, and it has a component that's collecting information, processing that information and guiding motor behavior. So in some sense, we've got the two difficult components already in place. What was, when I was talking about chess agents, I said, the early wave of AI was really devoted to trying to understand deliberation and these sorts of difficult decision tasks that we think of as uniquely human. But it turned out to be the hard part of AI was trying to understand, sort of the processing of sensory information, which doesn't obey which isn't which isn't the kind of intelligence that yielded to these more deliberative, kind of number crunching, logic-based parts of deliberation. So but we have learned how to do that to some extent. What we understand is that human intelligence is a combination of those two things. It's the embedded real-time, ability to process information. And then it's the centralization of that information in this much more high-level kind of process that is involved with making decisions. So it's the combination of the more sensory motor aspects of cognition and the high level intelligence that involves explicit representation, deliberation, number crunching.
And very well. And with that level of agency, freedom of will, it means that the actions of these systems are not determined by their physical constitution, or by what we as the designers might be able to decode into them. So it comes some sort of deliberation, decision making, and so on. Does this? I mean, there is no way of saying that they wouldn't be moral. I mean, they would be moral agents in that case, right? I mean, they are supposed to be capable of deciding to act morally or not.
So before I answer that, I want to back up to correct something that you said that isn't what I believe. So I do think that systems like this, just like us, would be subject to the physical laws. And in a deterministic context, there is one sense in which their behavior is determined and one sense in which it's not. So on the assumption of determinism, so putting aside issues about quantum mechanics and whether our world is deterministic, on the assumption of determinism, meaning even if we lived in a let's suppose for the second that we lived in a perfectly deterministic world, what would a system look like this? Or at least an effectively deterministic world, which means for purposes of describing systems at this level, the laws we can treat the laws as deterministic. What's true of a system like this? What's true of a system like this is, let's put aside relativity, which I actually think is relevant, but in a complicated way that it's probably, let's put aside for now. What that means is that a world, if you have the total state of the world at any given time, you can predict with certainty the behavior of all parts of the system at any other time. Okay? But what does that look like on the ground? What it means is that for a system like you and I, if we know everything about our brain state, together with every fact about the environment, down to the finest level of detail of the world as a totality, then our behavior can be predicted. But if you don't know, for example, it's not true, this is what's not true, that if we just know the state of the environment of a system like this, that we can predict its behavior. Why is that? Because obviously you need to know what the state of the brain or the internal state of the system is. For a system like us, that's equivalent to saying, before I know how you behave, I have to know your brain state. And what's involved in your brain state? What's involved in your brain state is what's encoded there is your hopes and your dreams and your plans and your projects and your goals and all of that stuff. Why is that relevant to free will? Because if you tell me that, yeah, I can't predict what you're going to do just by knowing the state of the environment, so your behaviors aren't governed or determined solely by the state of the physical environment. But in order to predict what you're going to do, I need to know your hopes and dreams and ambitions and goals and what's going on in your brain when you're making a decision. To me, that's like saying, it's up to you. It's not determined by the environment, it's up to you. The decision depends on all of the things that I would want my decision to depend on in order to understand that they come from me. They're not coming from the environment. So in the book, I defend, and I still believe, that the question of whether the world as a whole is physically determined is not undermining freedom of the will, so long as the part of the world that is me is an essential and integral part of determining what I will do. So with that qualification, and that's what I think the physics shows, with that qualification, then I want to say, questions of it's not that we're not part of the deterministically unfolding fabric of the world.
I understand that.
Yeah.
Very well. I wanted to build upon that to ask about the possibility of doing otherwise for this kind of systems and also for us. So, do you think that it would be possible for them and also for us to do otherwise? And if so, in what sense? I mean, do they go on, please?
Right. So yes, I see no reason that we couldn't construct, a physical system, a non-living physical system, like an artificial general intelligence that exhibited exactly this sort of cognitive organization. And I think that it would have the kind of freedom that we do. What kind of freedom is that? What does it mean to say a system like this could do otherwise? Here's precisely what it means. It means you could fix the environment in every physical detail and subject me to, to particular sorts of stimulus, or more generally, here's the way to put it. You could draw a sphere around my body. You could fix all of the facts about the physical environment. You could know the laws of physics and presume that the laws of physics are deterministic, and you wouldn't know, without knowing my physical state, what I'm going to do a minute from now. So here's what, and that's true also of any physical system. But what's interesting about us is that what we're going to do is part of the relevant part of our state to determining what we're going to do is the information encoded in the soft structure of our brain. That's highly individual. That's what represents or encodes all of the information that we've gathered over the course of our life. That's resulted into very particular, very personal hopes and dreams, a conception of who we are and who we want to be. So if we had an artificial general intelligence that was doing exactly that, that is, it was gathering information over the course of its history, and it was not just programmed with a goal that, like, for example, LLMs, they are programmed with a goal. The goal is next word prediction. So they gather information in the training phase, and they're given information, in the executing phase, about the strings of symbols that they're trying to predict the next word for. But they have a single fixed goal. We don't have a single fixed goal. And if we wanted to produce a human-like intelligence, we would have to let it choose its own goal. So it would gather information, be able to say it wouldn't just be programmed to move to the leftmost corner of a room, but it would have the capacity to form endogenous goals of its own. If it had all of that, then I see no reason why it wouldn't have the kind of freedom we do. I do think it would be a moral agent. We would have to take it seriously as, sort of a genuine human-like intelligence. So, and I think unless we want to do that, and I don't think we should want to do that. We shouldn't produce systems that have this structure.
All right. So, excellent. These are 30-minute conversations usually, and our time is almost up. But is there anything that you want to add to this conversation, which was superb and excellent, and we learned a lot? But is there anything that you want to add to the conversation that didn't come up during those far?
I guess there are a couple of things. I mean, when I look at sort of the trajectory that people who are building AIs right now, they don't really have there's so much progress, and it's been surprising in so many ways. But I think what's missing in it is this kind of cybernetic idea of, in particular, when you think about agency, of a system that's getting real-time feedback on its own actions, explicitly representing itself as an agent and understanding itself as, acting in the domain that it from, or that are, I think, arguably missing from these sorts of systems. Like, are they modeling the world? Are they doing causal modeling? I think if we want to do systems that are doing those things, we shouldn't be thinking, how do we build those in? We should be asking what it takes to grow those things. What sort of tasks would we have to give a system in order for it to naturally develop these sorts of things? And there, I think the cybernetic conception is what's really missing. It's different from, the lines of development that they're doing right now. But as I said at the last, in that last little bit, that last part of the discussion, I don't think we should develop AIs in that direction unless we are prepared to take very seriously that they would be real agents.
Very, very excellent. So on that excellent thought, we thank you very much for participating in this and giving this excellent talk. And I thank all our viewers for watching this program. Thank you very much, Professor Ismael.
Thanks so much.